Angela Yang, and today I'll be explaining the answers for the 2017 AMC 8. Problem 1 states, which of the following values is the largest? We have 5 options, options A, B, C, D, and E. Here, the really only easy way to do it is to just solve all the values. And we have to keep in mind about PEMDAS, which is parentheses, exponents, multiplication, division, addition, and subtraction, or order of operations. So if we use this method, we can find that the answer for A is 10. The answer for B, since 0 times 2 is 0, plus 1 plus 7, that makes 8. And then C is 2 plus 0 plus 7, which is 9. And in D, we have 2 plus 0, which is 2, plus 1 times 7, which is 7, which also again makes 9. Then over here, we have 2 times 0 times 1 times 7. And now if anything is multiplied by 0, that makes it 0, so this answer is 0. Therefore, the largest value here is A, and that value is 10. Problem number 2 states, Alicia, Brenda, and Colby were the candidates in a recent election for student president. The pie chart below shows how the votes were distributed among the 3 candidates. If Brenda receives 36 votes, then how many votes were cast altogether? So in this problem, we'll assume that the amount of votes cast altogether will be X. So if Brenda already has 30% of the pie chart, that's 30 out of 100. And that equals to the 36 votes that she got out of the unknown value, which is X. Now we can simplify this 30% into 3 over 10, which would still equal 36 over X. Now we can simplify this, now we can multiply this by 12, since 3 times 12 makes 36, and that means 10 times 12 would equal to X, and 10 times 12 equals to 120. Therefore, X equals 120, so the answer is E, 120 votes in total. Problem number 3 states, what is the value of this expression? So, in order to solve this, we have to first write it out and then solve it from the inside out. So, in this expression, we have the square root of 4, which is inside the square root of 8, which is inside the square root of 16. So, in order to first solve this, we must solve the square root of 4, which is 2, which means this is the square root of 8 times 2, and 8 times 2 is 16, and the square root of 16 is 4. So now we have the square root of 16, which is this number on the outside right now, times 4, which we got from this, which equals this 4. And then 16 times 4 makes 64, so this is the square root of 64. And the square root of 64 is 8, which means that our answer here is C, 8. So problem number 4 states, when 0.000315 is multiplied by 7,928,564, the product is closest to which of the following? So, in order to solve this, we should first take a look at the decimal places. So, we could easily round this number, or this decimal, to 0.0003, and this number to 8 million. Now, in order to make our multiplication easier, you don't actually have to multiply these two out. There's an easier way. You should first make 3 into a whole number by moving it over 4 decimal places, which means that 0.003 is now just 3. And then if you move this 4 decimal places, then you should take away 4 decimal places from this. So that's 4. And then you have 800. So that means 800 times 3 equals to 2400, which is D. So problem number 5 states, what is the value of this expression? So in order to solve this, we should simplify it. So if we figure out what's on the bottom, so 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 ends up making 36. The top is just 1 plus 2, 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8. So if we put this over 36, then we can simplify it. First, we can cancel out the 6 in this with the 6 and 36. So that means this will leave this with 36. Also, since 2 times 3 multiplied to 6, you can cancel them out too. And then 1 doesn't really add any value to the top, to the numerator. So then we're left with the numbers 4 times 5 times 7 times 8, and that's your answer. So this gives us 20 times 56, and then 56 times 2 is already 112, so add a 0 to the end, and that's 1,120, which is option B. Problem 6 says, if the degree measures of the angles of a triangle are in the ratio 3 to 3 to 4, what is the degree measure of the largest angle of the triangle? So, as seen as a ratio, we can see that 3 plus 3 plus 4 does not add up to 180 degrees, which means that it's technically the ratio of 3x to 3x to 4x. Now, these, all 3x, and 4x are supposed to add up to 180 degrees. And if you generally add them up, it makes 10x, which means 10x is supposed to equal to 180 degrees. And that means x, if you solve it, that means x equals to 18 degrees. Now, we're trying to find the large value of one of the angles of the triangle, which is 4x. So we do 4 times 18. And 4 times 18 equals to 72 degrees. So our answer is D, 72. Problem number 7 says, let Z be a 6-digit positive integer such as 247,247, whose first 3 digits are the same as its last 3 digits taken in the same order. Which of the following numbers must also be a factor of Z? So in order to solve this, we could first represent Z as ABC, ABC. Now using this, we need to find out the values of the ABCs and their sums in order to find out the common factors between them. So this first A is in the 10 to the power of 5 place, which means that A times 10 to the power of 5 represents the value it is in here. So if we continue with this, now we have all 6 represented over here. And now we just need to find the common factors between the A's, the B's, and the C's. So if we do that, we can represent them like this. So this first pair of A's would end up being A times 10 to the power of 2 times 10 to the power of 3 plus 1, because we need the other A. Then this next one would be A times 10 to the power of, B times 10 to the power of 1, or just 10, times 10 to the power of 3 plus 1. And then this last one, for C, would be C times 10 to the power of 3 plus 1. So if we factor it out, we can see that all 3 have one common factor, which is 10 to the power of 3 plus 1. So if we solve this, we get 1,000 plus 1, which equals to 1,001, which means that whichever number in here divides into 1,001 is our answer. So if we quickly calculate, we can figure out that 11 is the number that divides into 1,001, so that means A is our answer. Another way you could do this is you could just take a more simple number like 1, 2, 3, 1, 2, 3, and then continually divide all the numbers from it. Problem number 8 says, Malcolm wants to visit Isabella after school today and knows the street where she lives, but doesn't know her house number. She tells him, my house number has 2 digits and exactly 3 of the following of the 4 statements are true. So, from looking at this, we can instantly rule out statement number 1, because if a number is even, then it can't be prime unless it's the number 2, but since it's a 2-digit number, we can't include 2. Which means we can only follow rules 2, 3, and 4. Now, if you follow rules 2, 3, and 4, when you first look at rules 3 and 4, you think of the number 49, because it's divisible by 7, and one of its digits is 9. But 49 is not even, which means we have to multiply it by 2 in order to make it even, which gets us 98. And 98 follows all the rules. It's both even, divisible by 7, and one of its digits is 9. Now, the problem asks us for the units digit. So, because then the question is, this information allows Malcolm to determine Isabella's house number. What is its unit digit? So, its unit digit is 8. Therefore, the answer is D. It says all of Macy's marbles are blue, red, green, or yellow. 1/3 of our marbles are blue, 1/4 of our marbles are red, and 6 of our marbles are green. What is the smallest number of yellow marbles that Marcy could have? So in order to solve this, we first need to come up with a starting point as a number. So the number that we come up with for the number of marbles has to be divisible by both 3 and 4, which means that first number is 12. So if we try with 12, 1/3 of 12 is 4, so 4 blue marbles. 1/4 of 12 is 3, so 3 red marbles. And then 6 green marbles. So far that makes 13 out of 12, which means this cannot be the number of actual marbles, or else you're exceeding the limit of marbles you're supposed to have. Now our next number that's divisible by both 3 and 4 is 24. 1/3 of 24 is 8, so that's 8 blue marbles. 1/4 of 24 is 6, so that's 6 red marbles. So we have 6 green marbles, and so far that makes 20 out of 24, leaving 4 marbles to be yellow. Therefore, our answer would be D. 4 yellow marbles is the smallest number of yellow. Problem number 10 states, a box contains 5 cards numbered 1, 2, 3, 4, and 5. 3 cards are selected randomly without replacement from the box. What is the probability that 4 is the largest value selected? So in order to solve this problem, you need to know how to do problems like 4, choose 3. So this is basically in the format of n choose r, which is n factorial, which is when you multiply all the numbers from that number and down, over n minus r factorial times r factorial. So using this, since we have 5 cards and we're choosing 3, that's 5 choose 3, which is 5 factorial over 2 factorial times 3 factorial, which if solved out, you can cross out some numbers and you get the answer of 10. That means there are 10 total possibilities of the 3 cards for the 3 cards that you pick out. Now that we have 10 total possibilities, our answer will be out of 10, or if it's simplified, out of 5 or 2. So now in order to find out what is probability that 4 is the largest value selected, we obviously 4 will be one of the choices selected, but after that we only have 3 more options, which is 1, 2, and 3, and only 2 of these will be picked to match with 4. So in order to figure out the number out of 10, we will do 3, choose 2, because we're choosing 2 numbers out of these 3. So that gives us 3. So that means there are 3 combinations where 4 will be the largest number. So the answer is 3 out of 10, which is C. Problem number 11 states, a square-shaped floor is covered with congruent square tiles. If the total number of tiles that lie on the 2 diagonals is 37, how many tiles cover the floor? So in order to solve this problem, we could first use a smaller version or model. So on these 2 diagonals, there's supposedly a total of 37 square tiles, which means that the 2 diagonals share 1 square tile. And since they do share a square tile, that means that there's 36 tiles without counting the center one that they share, and divided by 2 equals to 18 because there's 2 diagonals. So on these 2 diagonals, supposedly, there's 18 square tiles without counting the one that the 2 diagonals share. And if you count that one, that means each one technically has 19. So each side is supposed to have 19 by 19, which means that the area of the square is supposed to be 19 squared, which if you calculate 19 by 19 makes 361, which is C. Problem number 12 states, the smallest positive integer greater than 1 that leaves a remainder of 1 when divided by 4, 5, and 6 lies between which of the following pairs of numbers? So in order to solve this, we should first realize that we need to find out the least common multiple of 4, 5, and 6. In order to do this, we need to first do a factor tree. So 4 goes into 2 and 2, 5 is just 5 and 1, and 6 is 2 and 3. So by doing this, we would multiply 2, 2, 3, and 5 to include all the factors. So that's 2 squared times 3 times 5, which makes 4 times 3 times 5, which equals to 60. So 60 is their least common multiple. Now, this number has a remainder of 1 when divided by these 3 numbers, which means we need to add 1 to 60, which makes it 61. So 61 is this number, and 61 goes in the range of 60 and 79, which makes our answer D. Problem number 13 says, Peter, Emma, and Kyler played chess with each other. Peter won 4 games and lost 2 games. Emma won 3 games and lost 3 games. If Kyler lost 3 games, how many games did he win? So, in this case, this is all the information graphed, and then this is actually Kyler. So, technically, the number of games lost and the number of games won for each person should be equal. So we could put this into an equation. We can add up all the lost number of games, which is 2 plus 3 plus 3, equals to the number of games won, which is 4 plus 3 plus, let's say, x for Kyle. And then, if we solve this, we get 8 equals to 7 plus x. And if you subtract 7 from each side, you get x equals to 1, which means that Kyle only won 1 game. So that means the answer is B, 1. Problem number 14 states, Chloe and Zoe are both students in Miss Demeanor's math class. Last night, they each solved half of the problems in their homework assignment alone and then solved the other half together. Chloe had correct answers to only 80% of the problems she solved alone, but overall, 88% of her answers were correct. Zoe had correct answers to only 90% of the problems she solved alone. What was Zoe's overall percentage of correct answers? So in order to solve this, we could first depict this problem using a model. Since they both did half together and half by themselves, we could say that this represents Chloe's amount. So she did 80% accuracy by herself, but overall her average was 88%. Now we want to find out what percent of answers they got accurately together, because that's in order to find out Zoe's overall. So by doing this, we could do 88 times 2, because there's 2 halves, and then that gives us the answer of 176, and 176 minus 80 gives us 96, which means they solved 96% of the problems, of half of the problems that they did together accurately. So now we have Zoe's model. So for her, she did 90% correct alone, and then now that we know she did 96% correct together with Chloe. So now that we have this, the total makes 186. Now we need to find our average. So we do 186 divided by 2 because there are 2 halves, and that gives us the answer of 93. Therefore, 93% overall is our answer. So Zoe's overall percentage of correct answers was 93%, which is letter C. Problem number 15 says, in the arrangement of letters and numerals below, by how many different paths can one spell AMC 8? Beginning at the A in the middle, a path allows only moves from one letter to an adjacent, above, below, left, or right, but not diagonal letter. One example of such a path is traced in the picture, which is this path. So, in order to solve this, we could first realize that there are 4 of these kinds of squares with the exact same arrangements throughout this combination of numbers and letters, which means if we find out the amount of combinations in one of these squares, we can figure out the amount of combinations in the whole entire sequence. So, we could start off by using this square. So first, we could draw it off to the side. So it has 8, C, 8, and C, M, C, and then M, A, M. There's only one A, and that is in the center. So this is basically the center of the whole structure. So first off, we could start off by going to the side. So this is 2 combinations, and then 4, and then 6. Which means there's 6 combinations for one of these parts. Since there's 4 parts, that's 6 times 4, which equals to 24, which gives us our answer of D. Problem number 16 states, in the figure below, choose point D on line BC so that triangle ACD and triangle ABD have equal perimeters. What is the area of triangle ABD? So D could be anywhere on this line over here, so let's just assume that it's over here. So that means it would have to, line have to split down, and this is ACD, and this is ABD. So since they have equal perimeters, we could first represent the perimeters in a certain way that could help us figure out the value of this area, which we'll assume is X for now. So the perimeter of triangle ABD is AD, line AD, over here, plus X plus 4, which should equal to the perimeter of triangle ACD, which is line AD plus 3 plus 5 minus X, because this total area or total length over here is 5. So we can solve this by first eliminating the line AD. Now we have X plus 4 equals to 3 plus 5 minus X. And then if we solve for X, then we find out that X equals to 2. So we're going to write that over here. And then, okay. So now that we know X equals to 2, we can label this value as 2. And that means that this area over here is 3. So from here, we could draw the height of this triangle ABD by making it perpendicular to line AB, where there's a right angle. Now, if you look closely here, you can realize that this right triangle that we've drawn is proportional or similar to the larger right triangle, because they both share a 90-degree angle, and they share this angle. They share the value of this angle, which means this angle must be equivalent to angle ACB. That means that this right triangle and this right triangle are proportional. Now that would also mean that the height of triangle ABD is proportional to the height of line AC, which would mean basically that which would basically mean that line DB, which is over here, over BC, which is the total over here, since these two must be proportional and equal to one another, would equal to line DE over line CA. And since we already know the value of DB, which is 2, and the value of BC, which is 5, we don't know the value of DE, but because we'll assume this is D, we'll assume that this point drawn down here is E. And then we have CA, which we do know, and CA is 3. So basically, and then we have 2/5 equals to DE, which is an unknown value for now, over 3. We could solve this by multiplying each side by 3, and we end up with DE equals to 6/5. That means the height of triangle ABD is equal to 6/5, 6 over 5. So in order to find the area of a triangle, we have the equation 1/2 times base times height. So in this case, we could use this. The height is 6 over 5, and the base is 4. So it's 1/2 times 4 times 6 over 5, which we can make into 2 over 1 times 6 over 5, which equals to 12 over 5, which is our answer for the area of triangle ABD. And that's also letter D, so our answer is D. Problem number 17 states, starting with some gold coins and some empty treasure chests, I tried to put 9 gold coins in each treasure chest, but that left 2 empty. So instead I put 6 gold coins in each treasure chest, but then I had 3 gold coins left over. How many gold coins do I have? So let's assume that the number of gold coins is G and the number of treasure chests is C. So using this we can develop 2 equations to match each other. If I had 9 coins in each and then I had 2 empty in the end, that means I had 9C, 9 coins per each, but 2 chests empty means I had 18 coins that I needed in order to fill all the chests. So that's minus 18 equals 2G. Now, starting with 6 coins. If I had 6 coins in each, that's 6C with 3 coins left, so plus 3, because I didn't get to use 3 coins, equals to G. Since these both equal to G, we can make them equal to each other. So we could do 9C minus 18 equals to 6C plus 3, and we could solve this out. So if we solve it out, we end up getting that C equals to 7. Now C equals to 7, that's the number of chests. So we could just sub in C into one of these equations to find out what G is, which is the total number of coins. So 6 times 7 plus 3 equals to G. That's 42 plus 3 equals to G, and then 45 equals to G. So our answer is 45, which over here is C. So our answer to number 17 is C. Problem number 18 says, in the non-convex quadrilateral ABCD shown below, angle BCD is a right angle. AB equals to 12, BC equals to 4, CD equals to 3, and AD equals to 13. What is the area of quadrilateral ABCD? So in order to solve this, we could first label all the values. So AB is 12, BC is 4, CD is 3, and then AD is 13. So when we look at this figure, we should be able to notice that using the Pythagorean theorem, we can figure out what this side is, even though it's an imaginary side. And then you figure out that it is 5. So 5 times 12 makes 60. 60, since this is a triangle, divided by 2 equals to 30. 30 represents this triangle, including this empty space here. Now we want to get rid of this space to figure out the actual area of ABCD. So we multiply 3 by 4 to get 12, and then since this is a triangle, we do 12 divided by 2, which equals to 6. So that makes 30 minus 6, which equals to 24. So the area of this quadrilateral ABCD is 24, which is B. Problem number 19 says, for any positive integer m, the notation m factorial denotes the product of the integers 1 through m. What is the largest integer, n, for which 5 to the power of n is a factor of the sum 98 factorial plus 99 factorial plus 100 factorial? So in order to solve this, you would first start off by writing down this equation. So it's 98 factorial plus 99 factorial plus 100 factorial. And now, as you notice here, we can factor out the 98 factorial because 98 factorial appears in every one of these. So we can get 98 factorial times 1 plus 99, plus 1 times 99 plus 1 times 99 times 100. Since this is 98 factorial times 99 times 100, and this is 98 factorial times 99. So now we have this, we can simplify this to become 98 factorial times 1 plus 99 plus 99,900, and this makes 10,000, which means it's basically 98 factorial times 10,000. Now we need to find out how many 5s go into each of these. So for 98, we already have 19 5s, not counting, it's not 20 because we're not counting the 5s in the 100, plus 3 because 3 of the numbers from 1 to 98 have 2 5s, and those numbers are 25, 50, and 75. So now we know 98 factorial is 22 5s, but now we need to figure out how many 5s 10,000 has. So 10,000 can easily become 10 to the power of 4, which is basically 2 times 5 to the power of 4. So if we simplify this, we get 2 to the power of 4 times 5 to the power of 4, which means there are 4 5s in 10,000. So we take this 4 and add it to 22, which makes 22 plus 4, which equals to 26 5s in total, which is letter D. Problem number 20 states, an integer between 1,000 and 9,999 inclusive is chosen at random. What is the probability that it is an odd integer whose digits are all distinct? So in order to solve this, if it means that all digits are inclusive, that means we would do 9,999 minus 1,000 plus 1 because it's inclusive. So we need to include the 9,999, which makes 9,000. So this is out of 9,000 possibilities of numbers, or of any combination of numbers that have 4 digits. So first of all, we start off with the units digit. The units digit only has 5 possibilities because there are only 5 odd numbers that can be put here. Now we go to the thousands place. So for the thousands place, there's only 8 possibilities because it can't be 0 and it can't be the number in the units digit. So that's 8. Then in the hundreds place, there are also only 8 possibilities because now it can include 0, but it also can include the number in the thousands place and the number in the units digit. And then for the tens place, there are only 7 possibilities because it can include 0, but it can't include the numbers that are already in the units digit, the hundreds place, and the thousands place. So if you multiply all these numbers, you get 8 times 8 times 7 times 5 over 9,000. Now you can simplify 9,000 into something easier to cross multiply or cross simplify by. So you could do 200 times 5 times 9. If you did that over 8 times 8 times 7 times 5, you could cancel out the 5s, and now you could change 200 into 25 and 8, and you could cancel out one of the 8s. So now you have 25 times 9, so that's 56 over 25 times 9. And if you solve it out, 25 times 9 is 225. So your final answer is 56 total possibilities of having odd integer whose digits are all distinct of 225, which is your answer of B. Problem number 21 states, suppose A, B, and C are non-zero real numbers, and A plus B plus C equals 0. What are the possible values for A over the absolute value of A, plus B over the absolute value of B, plus C over the absolute value of C, plus A times B times C over the absolute value of A times B times C? So in order to solve this problem, we should first make a chart, and then just do, it's kind of like a trial and error kind of thing. So we know that A and B and C have to equal to 0, which means we could do, one of our possibilities could be -1, 2, and then -1. In this case, A times B times C would then be 2. And then the equation, when plugged into this equation, over here we would get -1 plus 1 minus 1 plus 1 equals 0. Now if we do this for a while, we notice that whenever there are 2 negative 1s and added to 2 positive 1s, it always makes a 0. Which means that if you do A times A, B, and C, and then and you multiply them together, and two of the numbers end up being negative and two are positive, that means your answer will be a 0. So we could do another example, which is 1, -2, and 1, which multiplied together makes -2, and then when plugged into this equation makes 1 minus 1 plus 1 minus 1 equals to 0. Same thing with 1, -3, and 2, -2, 1, 1, and 1, -4, and 3. And if you solve out all these values, you find that they all make 0, which could lead us to the conclusion that the answer will always be 0. So that means that the answer would be A. Problem number 22 states, in the right triangle ABC, AC equals 12, BC equals 5, and angle C is a right angle, which means it's 90 degrees. A semicircle is inscribed in the triangle as shown. What is the radius of the semicircle? So we know this is a right triangle, and using the Pythagorean theorem, which is a squared plus b squared equals c squared, we can figure out that c, or this value over here, is equal to 13. That means AB equals to 13. Now that we know that, we can realize that this problem is very similar to problem number 16, in which that we can see that we can label this value, the radius, as r, which means r can also stretch up to here. So let's assume that does, and that makes a 90-degree angle and is perpendicular to line AB. If that's the case, we can realize that this point is D, so this point is D over here. This point is E, the place where it touches the spot on line AB. So now that we see this, we can realize that triangle AED is similar to triangle ABC, in which they both share a 90-degree angle and they share angle BAC, which is this angle. So now that we see that, that must mean we can make a ratio equivalent to one another. So that means AED, which is the radius, over BC, which is 5, would equal, because this is the ratio, because this is the bottom of this right triangle, and this is technically the bottom of this right triangle, would equal to AD, which is from A to point D, so it's 12 minus R, over AB, because this is the sideline and so is this. So that would mean that our answer would end up, or we could make this into the ratio of R over 5 equals to 12 minus R over 13, because AB stretches over here, since they're equal to one another, because this is the value across and so is this value, or like the hypotenuse. So in order to solve this, we can multiply both sides by 5 and then figure out what R is. So R equals to 12 minus R. Like multiply both sides by 13, and then we get 13R equals to 60 minus 5R. Add 5R to both sides. We get 18R equals to 60. When we divide each side by 18, we get R equals 60 over 18. Now that we know R equals 60 over 18, that is the radius. We can simplify this into 30 over 9, which goes to 10 over 3, which means 10 over 3 is the radius of this semicircle that's inscribed in the right triangle ABC, which means our answer is letter D. Problem number 23 says, each day for 4 days, Linda traveled for 1 hour at a speed that resulted in her traveling 1 mile in an integer number of minutes. Each day after the first, her speed decreased so that the number of minutes to travel 1 mile increased by 5 minutes over the preceding day. Each of the 4 days, her distance traveled was also an integer of number of miles. What was the total number of miles for the 4 trips? So in order to solve this, we could first start off by making like an average for speed. So if it's 1 hour, that's 60 minutes over, let's say she travels 1 mile in X minutes, so over X, would be able to tell us how many miles she traveled in the first day. And the second day, her speed, or the number of minutes, is added. That's 5. The number of minutes, so 5 minutes is added, so the next day would be 60 minutes over X plus 5, because it took her 5 more minutes, plus 60 over X plus 10, plus 60 over X plus 15. This is the 4 days that she did this all in 4 days. Now in order to solve this, we could first see, since it's 60 minutes and it is an integer, that means it must be a whole number. So that means X needs to evenly divide to 60, X plus 5 needs to evenly divide to 60, and same thing with X plus 10 and X plus 15. So the only number that would work with this, if you figure it out, is 5. 10 doesn't work because 35 cannot go into 60. So that means X equals to 5. So this is not our answer though. Our answer would be, since it takes X minutes, we solve out all of these. So we sub in X. So that's 60 over 5 plus 60 over 10 plus 60 over 15 plus 60 over 20. So that would make 12 plus 6 plus 4 plus 3. And this makes 12 plus 13, which is 25. So that means that Linda travels 24 miles in all for the 4 days, or 4 trips, which is letter C. Problem number 24 says, Mrs. Sanders has 3 grandchildren who call her regularly. One calls her every 3 days, one calls her every 4 days, and one calls her every 5 days. All 3 called her on December 31st, 2016. How many days during the next year did she not receive a phone call from any of her grandchildren? So in order to solve this, we could do 365 times 2 over 3 times 4 over 5 and times 3 over 4 times 4 over 5. We do this because every 2 out of 3 days, grandchild A, let's assume these are 3 grandchildren, A, B, and C, doesn't call her. Every 3 out of 4 days, grandchild B doesn't call her. And every 4 out of 5 days, grandchild C doesn't call her. So we can make it hard on us by doing 365, but we can do 360 instead. If we do 360 times 2 over 3 times 3 over 4 times 4 over 5, we can easily cancel out some of these. And then we just have 360 times 2 over 5, which we can easily determine. So if we do 360 divided by 5, we get 72. So that's 72 times 2, which equals to 144. Now we're not done here yet, because we still have the numbers that are from 360 to 365 that we didn't include. And if you figure out some of those, and if you figure out which numbers from those 5 numbers are not divisible by 3, 4, or 5, you find out that those numbers are 361 and 362. And therefore, your answers should, then this is 2 more numbers. So you add these 2 to 144 to make it 146. And that means that the total number of days that none of her grandchildren called her in 2017 for the next year is 146, which leads us to the answer of letter D. Problem number 25 says, in the figure shown, line US and line UT are line segments, each of length 2. And M, angle TUS, equals to 60 degrees. M is over here. So, arcs TR and SR are each 1/6 of a circle with the radius of 2. what is the area of this region shown? So in order to solve this, we could first label, pretend that this is a full triangle, and the radius is 2. Which would mean these two sides would be 2. And then this area over here, these line segments, would also be 2. So now that we have that, we could find the total area of the triangle, and then later on subtract these two parts from it to find the region. So in order to find the total area of this triangle, we first need to use the original equation, which is 1/2 base times height. So we already know that the base is 4, but we don't know what the height is. So in order to solve that, we could use the Pythagorean theorem, because this is a right angle. So by doing that, we could do a squared plus 2 squared equals to 4 squared, which goes to a squared plus 4 equals 16. Subtract the 4, then you get a squared equals to 12, and you square root that, and you get a equals the square root of 12, which you can simplify to become a equal to 2 rad 3. Now that we have the height, we can find out the area of this whole triangle over here. So by doing that, we have 1/2 base, which is 4, because 2 plus 2 is 4, times height, which is 2 rad 3. So times 2 rad 3, and then we get 2 times 2 rad 3, which makes 4 rad 3. So that means that 4 rad 3 is going to be the total area of this triangle. Now we need to find the value of these two smaller parts of a whole circle in order to find out the area of this region. So let's assume these two triangles are called A and B. Let's assume that when A and B are added together, they do make 1/3 of this circle. So let's assume this is like the circle. They make a big pie or something. And then if A and B are 1/3 of this circle, and then the radius is 2, that means the area of the circle would be pi r squared, which is pi times 2 squared, which is basically 4 pi. So the area of this total circle over here, including these two pieces, is 4 pi. Now we need to find out the area of just these two pieces alone, which means it's 1/3 of 4 pi. So we do 4 pi times 1/3, which gives us 4 pi over 3. Now that we know the area, that's the area of A and B combined, we subtract this from the total area, which is 4 rad 3. So we do 4 rad 3 minus 4 pi over 3, and we can't simplify this any further, so that's the answer. And then we match it up to one of these following options, and then the answer is supposed to be letter B, 4 rad 3 minus 4 pi over 3.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramathcircle.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the end. So bye!